blockchain. So actually, I might ask somebody from the audience. Anybody want to throw out like a answer of what a blockchain is? This guy was smiling, so like I don't know if he wanted to tell me.
Guys, could we please use the microphone? I've got one up here. If someone could just pass it down for me.
Sure.
Oh, this is the one for Q&A. So.
Cool. Now we're going to really put you on the spot with the microphone.
Is it a hashed linked list?
So yeah, so kind of like fundamentally, it's like kind of a hashed linked list of transactions, right? So that's kind of a really cool, very technical answer, but that doesn't really tell us like what is a real blockchain. So I'm gonna probably put this away here so I don't get feedback. So who here has heard of like something like Bitcoin? Has anybody heard of Bitcoin? Obviously, most of this room probably while you're in this talk. So everybody thinks blockchains are just about transferring currency and transferring like data between users. So like I kind of want to like show that we can use actually blockchain for a lot of other things. Kind of what I'm most interested in, if I can actually get, I guess this thing is going to just really just mess with me here. What are some other really interesting things that blockchains can do that we can't do with other technologies? And you know, we have money transfer, things like Bitcoin. We have immutable ledgers. So like if we want to keep track of balances between multiple parties. So like let's say that we're building a stock exchange among people that we don't trust. We can build a ledger of buy and sell orders between 100 different parties, and we can ensure that we can trust them through a blockchain. The area that I'm most excited about and that I work on the most is game assets. Like, how many people here are gamers? Anybody here a gamer? Like only, okay, half the room. Okay, I was a little bit worried there. We're at a programming conference. So what I really think is interesting is that what if we owned the characters that are in the game? What if we owned the swords or the shields that we have in the game? What if they were actually digitally ours? What if we could sell them? What if we could trade them? And this is like, I think, one of the most exciting things that the blockchain has to offer. And what's really kind of growing right now is this stuff called tokenized equity. What if we could take a startup and instead of just issuing shares, we issued tokens. And these tokens could be traded in lieu of equity. And we could have liquidized exchanges of equity for startups. I think this is probably the most profitable area right now in blockchains, and you've probably heard a lot about this. You've heard about ICOs and stuff like this. And this is kind of the area that's kind of probably the most heated and debated. And I probably think what's kind of really should be exciting to this audience is there's new ways to monetize protocols. So like used to be when we built a protocol, we built TCP, we built DNS, you couldn't make money. The guy that wrote TCP, the guy that wrote SMTP, they couldn't make money off of a protocol. But what's kind of interesting about blockchain protocols is you can actually have economic models behind them. And you could actually charge usage. Like say if we built an SMTP on top of a blockchain, we could actually have built-in payment mechanisms for sending or receiving emails. Does it make sense? I don't know, but there's definitely a lot of really new opportunities that really didn't exist before. So before we step back, there's obviously two big blockchains. Obviously, Bitcoin. We saw about 15 people here in the audience knew about Bitcoin. But the thing that I'm kind of more excited about is Ethereum, which is also written in Go, or the main implementation is. Has anybody here actually gotten to play with Ethereum? Oh, cool. Only about 4 or 5 people. So awesome. I'm really excited to tell people more. So kind of what blockchains used to be was Bitcoin. I can transfer money to you, you can transfer money to me, we can trade money. But what if we had a universal programming language on top of the blockchain? What if we could write a piece of code that was a contract that ran in a decentralized manner? So that way we could have a piece of code that says, on Thursday the 27th, I'm going to release $100 to him, or I'm going to transfer this money to this person. Or if you send me this much money, I will give you these items in a game. And all of a sudden, we can have a decentralized computer that everybody can use. And now we're kind of at the stage where we're trying to figure out, now that we have this decentralized computer, what kind of interesting applications can be built on top of it? And before we get on, just to give the audience like a little bit of background about a blockchain, is that they're really just a specialized database. You can kind of think of it as a linear, eventually consistent database that only allows one transaction at a time, and the transactions have to be ordered, and they're always going to be consistent across all the nodes. Where it kind of deviates from a traditional database is that multiple different parties will run the nodes. So somebody in China, somebody in America, somebody in South America could be running different nodes, and those nodes of the database are working together. But we have economic incentives that make it so that people can't cheat other people. And we have all kind of hip cryptographic means to make this happen. And we're kind of going to delve into that throughout this talk. So first off, one of the ways I like to think about blockchains is from kind of traditional app development is like the CRQS model, right? Where basically everything in a blockchain is we have some kind of transaction that comes in. We're going to write to our mutable state, whether that state's a ledger, it could be an application, it could be a smart contract, and then we're just going to create a materialized view up until that point in time. Even though blockchains are immutable in the sense that we can never remove transactions from the history, we always have a materialized view of the current state of all the blockchain. So it's still very similar to traditional architectures in that aspect. But one last place where blockchains deviate from regular databases is, in regular databases, we just have transactions, right? So we have, like I update a row in the user table, I insert this record, I delete this record, but we also have blocks. Because we'll be propagating this data across thousands of machines, across hundreds of countries, we want to kind of organize these transactions into logical blocks to make it a lot more efficient to send it over the network. So a lot of times, like in Bitcoin, we'll have a 1 megabyte block. So we may have 100, 200 transactions per block. And that's why they're called blockchains, because we organize our transactions into blocks. And that makes it easier to cryptographically sign them and transmit them. So cool. You're like, Matt, okay, cool. I kind of got the idea of the very basics. And I know I'm kind of running through fast because I'm trying to explain a whole industry here in a 40-minute talk. But what is really fun? And for me, it's games. And kind of what my startup is doing is actually building games on the blockchain. And I don't know if anybody here has ever tried to run a game on the blockchain, but most of the games on the blockchain are incredibly boring Ponzi schemes, essentially. But what's really kind of cool is the blockchain kind of opens up a lot of new possibilities. So traditionally, let's say that we used to have a video game, like a server-based game like World of Warcraft or Ultima Online or something like this. The users wouldn't have access to their data. In blockchain, everybody can see all the data that happens in the game. If a user wants to fork the game and create their own blockchain, they can literally just take the entire data set, run their own instances of the game, and add a certain version of the code. And we also have real ownership of assets. So what I do is actually, I build a battle card game, kind of like Hearthstone, but on the blockchain. But what's kind of cool is now people can own the cards. It's kind of like when you were in high school, or at least when I was in high school, we actually played this game called Magic the Gathering. And we literally would trade cards with our friends, or we would bet cards on matches, right? So we go back to this era where we actually have ownership of our digital items, and the items are digitally scarce. And what's pretty cool is because all the data is on the blockchain, you could actually mine all the games and find out the best strategies. You could do like chess rankings for video games. And if you wanted to change how this game works, you could literally just fork our blockchain and run your own instance of the blockchain and run it with different data. Or we could even allow you to upload new smart contracts to our blockchain. So it's kind of the next evolution, I think, of kind of server-side gaming. So I want to step back for a second and talk about the hotness right now, which is the serverless, which is serverless programming. Everybody's always talking to me about serverless. It's like, Matt, serverless is the future. So you can think of like programming on the blockchain as the exact opposite of serverless. So like with serverless, we have like a single function that runs, and we try not to mutate any state, or we have like a very kind of stateless service. With blockchain, we have like a single function that runs, but all it does is mutate state. It's literally like embedded in the database. So we can think of it like we're almost building our entire application into the database, which is kind of like the antithesis of like everything we've learned up until this point. So it's kind of interesting. So we now have these things called smart contracts. Has anybody here, I'm gonna just throw this at the audience here, but has anybody here ever written a smart contract? Or played with one? This one guy? Cool, too. What did you make with your smart contract, or what was your opinion?
Well, one was on Ethereum, a token-created registry. So you have a self-curating list, and a lot of enterprise smart contracts. So shared business logic, basically.
Cool. That's cool. So what is it's good. There's only 2 people here that have written a smart contract. I'm hoping after this talk, everybody go and try to write one smart contract, maybe not in Go, but Solidity or something like that, and just try it out. But basically, what a smart contract is, it's a program that runs on the blockchain. So what happens is you upload your program onto the blockchain as actually data in the blockchain, and you send a transaction to that contract. And when you send that transaction, it actually executes. So your smart contract could send tokens to other people. It could create new tokens. It could store data. It can do any kind of thing that's digitally possible inside of the blockchain. So it's cool. So let's step back. Just really quick about me. I'm the founder of Loom Network. We kind of build blockchain SDKs and Go. So we're big fans of Go. I used to be over at DigitalOcean, if you've seen me before. And I rode an elephant to my wedding. It's just kind of a random fun fact about me. It's kind of a, oh yeah, and I flew here 14 hours from Thailand. So I'm not sure, did anybody here fly farther to come here than me, or? Nope. Maybe Corey? How far did you fly? 8 hours. Very close then. Cool. And one other thing is, if you guys want to know more about blockchains, programming blockchains, you can pick my ear after the conference, or we actually have a hackathon this weekend here in London. That's kind of why I'm here. So you guys are all welcome. I'll sneak you guys in even if you haven't registered, and you can find out more about actually coding apps on the blockchain. So cool. So you're like, Matt, okay, cool. All right, so this blockchain thing, it sounds kind of interesting. Smart contracts, okay, whatever. What does this have to do with Go? Why? I'm here for a Go conference, Matt. Talk to me about Go. So we build all of our blockchain technology in Go. And I kind of wanted to like dig down a bit and talk about what does it actually look like in Go? What are the actual fundamental pieces that are actually building these blockchains? So you have just a better conceptual understanding when you go to write your own smart contracts. So this IR is going to kill me here. So basically, a smart contract is a really, really, really simple interface. And I'm sure you can't actually read that from the back of the room, so don't worry, I'll kind of go through it. So really, there's only 2 methods on a smart contract. There's a call, and then there's a static call. So basically, there are transactions that are writable, and there are transactions that are read-only. So with a blockchain, transactions that are read-only are always free, because every single node in the blockchain has the entire state of the world. So it's very cheap and free to have read-only state. So it's very important to differentiate if a function is going to support reading or writing. And what we have to do is a smart contract is very condensed in what it can do. It can only read data, write data to different keys, and basically that's it. But some of those keys, for example, are transferring tokens or calling other functions in other smart contracts. So if I want to transfer tokens from me to him, I can actually call a function in another smart contract. And all that function does is ultimately change the values in the ledger of moving the data between the two people. What's kind of really interesting about smart contracts is this has to be 100% deterministic. You can't have any code in here that would ever run differently on any node. So if anybody here has ever run like a Cassandra instance, and you know that like your data is kind of sometimes different on different nodes, and like sometimes that's okay, you can't do that on a blockchain. So like literally after every single commit on a blockchain, you generate a hash of that commit. And if it doesn't match on the other nodes, then you have to throw away the data. And you consistently do that on every single transaction. So there's always very, very strong consistency on the data, on the actual blockchain itself. And I kind of wanted to also kind of show what a smart contract looks like in Go. You won't see most of these because right now most people are writing smart contracts in Solidity, but that's what we're trying to change. We're trying to make more blockchain development be done in Go. So if we look at a contract here, this is like a really simple contract that can set and get data. And it also is emitting events. So basically it's very simple. We're just setting keys, reading keys, and we can emit data. So like sometimes what will happen is you'll send a transaction onto the blockchain. And you'll want events back from it. Like, okay, the event, I transferred these tokens to this user. Or this person now owns this asset. And these are the kinds of things that we can actually write in a smart contract. And it's just really, really simple Go class, right? But here is where Go actually is one. There's a bunch of downfalls of why Go is actually not the best language for doing smart contracts. So we talked about determinism before. And what is the biggest issue with determinism? Randomness. What is the biggest weird thing that Go does that's random is the ordering of maps. So like you're writing it, you're like, oh man, this is great. My code is actually 10 times faster when I write it in Go instead of Solidity. It's all fast. And then all of a sudden you're like, oh, all my nodes don't come to consensus because I'm using Go maps and the order is random. And now the output of my data is random. And you never thought about that before because if stuff is slightly different on different nodes, you never really cared that much in most programming. But because you're trying to do 100% deterministic code, it starts to run into issues. So the other thing is time. We don't realize this, but we use time a lot in our programming. And you can't use time at all in a deterministic program. The only time you get is access to what was the time of the last block, because that's a deterministic value. So, and we can't use Go routines. We can't have threading. Any kind of threading is non-deterministic by nature. So you can only do a single thread of execution, and you have to have a very limited programming set. But you get the advantage that Go ends up being about 10 to 100 times faster than other smart contract programming languages because it's natively compiled. So I would be at loss not to talk about Solidity. So normally, Solidity is the #1 programming language for smart contracts. I haven't talked much about it because we're at a conference for Go, and I've seen some other blockchain talks at Go conferences, and I really wanted to show that Go is actually very capable of doing blockchains. But I do want to talk about Solidity, so if anybody here ends up deciding they want to get into blockchain development, it's really important to start trying out Solidity. And Solidity is kind of like one of these horrible languages like JavaScript that somebody wrote over a weekend, like probably half awake, and it ended up being the de facto programming language. It's not very good, but it's very available. So like if you use the Ethereum blockchain, you'll see this language called Solidity. And it's kind of a hybrid of JavaScript looking, but it doesn't have any non-deterministic features, which is really nice. And it also doesn't have floating point math, which I didn't realize, but floating point math is also non-deterministic because it works differently on different CPUs. And like, there's an amazing amount of things when you start to get into this, you realize that you never realized before actually really matter, that we're actually deterministic and we're causing little tiny issues everywhere, but you just didn't know and it didn't matter that much, right? Cool, awesome. How do I start? Matt, we've been talking about like what are the internals of a blockchain, what is a smart contract, how do we get started? And like I said, like if you just want to get started and you just want to play with this and you just want to play this tomorrow, just grab Ethereum, which is written in Go, but use their language Solidity. Just try that, that's really easy. But if you want to have fun, because we're Go developers and we want to build our blockchain in Go, there's actually a couple frameworks. So not to plug our own stuff, but there's Tendermint, which is probably the most popular Go framework for doing building your own blockchain. So it's like, you can think of it as like almost at the raft or like at the consensus layer. And it has all the primitives you would need to build your own custom blockchain in Go. And then we have our SDK, which is kind of like a layer above it, which provides like Go smart contracts above it. And there's a few other ones. But basically, I would start with something like Tendermint, which is like really low level. And you can kind of really get to see how blockchain really works. Because I think what's going to be really the big win from the Go community is basically Go has been building all the infrastructure of the web, right? We've seen that the #1 DNS server on the internet is in Go. A lot of the new HTTP servers are written in Go. A lot of the major, almost every single metric system now is written in Go. So I think we're going to see more and more of the blockchains be written in Go. And I kind of hope that this is a gateway where if you see a blockchain project in the future, that we'll see that actually all the core infrastructure will be written in Go. I would be remiss not to talk about economics. So the thing about blockchains and that they kind of very differ, because you're like, well, why is this really different than a regular database? It's because we have economic incentives, and different chains have different models for economy. So for example, with Bitcoin or Ethereum, every time you send a transaction on the network, you pay a fee. And that's how they ensure that you're not going to spam the network and that the network has money to pay for itself, right? So it's kind of like this self-perpetuating computer, because every time somebody does something on it, they're paying. So that means that all the people that are running the computers, the miners that are actually running the chain, they're making money. And that's how they're able to continue running this world computer, because it costs money on each transaction, right? So a blockchain that has no fees and no economic model isn't a blockchain, because ultimately you'll have no security. But there is kind of some alternate models where like either the people that write the smart contracts pay, or sometimes the users will hold a certain number of tokens as equity or bonding. So there's a kind of whole slew of economic models, but like the economics is actually one of like the biggest areas of the blockchain, both from a math and from like just a pure game theory perspective. Yeah, oh, and so it's like, I kind of want to talk about it, but it's a whole talk in itself, that there's different models. So like probably people have seen things like proof of work. And right now, most of the blockchains are built on this method where there's like a cryptographic puzzle that has to be solved. And if you solve this cryptographic puzzle, like every 15 seconds, you win a Bitcoin. But that's what secures the network, and it makes sure that people are spending computing resources and making sure that the network is secure. But there's other models, like proof of stake, which is coming out, where it says, I'm going to hold 100 Bitcoins, and because I hold 100 Bitcoins, I'm very much less likely to attack the network. And if I do attack the network, or I do try to cheat the network will take some of my Bitcoins back. So there's like a lot of really interesting models around economy. Oh, consensus. This is a big, big topic. I know Corey's a big Raft guy. Just out of curiosity, has anybody here actually had to like delve into Raft or actually use it directly? You have, I know that. There's one other person. What did you have to use Raft for, by the way? That is good. I don't think the mic heard that, but she said that she used Raft to tell everybody that it wasn't appropriate for a project. I'm going to go ahead and tell you right now, you probably don't need to use Raft unless you're building your own database. And then all of a sudden you do need to use, well, maybe. Maybe. If you're going to build your own database from scratch in Go, or if you're going to build your own blockchain from scratch, which very, very few people do, but it's still a fun project to work on, right? So that's when you start to get into things like consensus. That's when we start to talk about things like Paxos, and like we've used probably Zookeeper and all these kind of technologies. So like, obviously, probably the most popular one in the Go world is Raft, right? And I'm sure a lot of people have actually seen this, where basically what happens is that there's different leaders. And most consensus systems work on the principle that there's different leaders, and at different points in time, different leaders are actually committing the state into the database, right? And then everybody else verifies that that leader is correct. And there's like usually a voting system that determines, that says, okay, no, that leader is actually cheating, or is he's malicious. Now, most systems like Raft and Paxos really don't have much in the way of maliciousness, because they're usually run on private networks by groups of peers of things that are not trying to attack each other. They're generally speaking trying to be good neighbors. Sometimes they'll just have wrong results, but they're not, generally speaking, people aren't trying to attack the network. But what's kind of interesting is, with the blockchain stuff, there's kind of another level, which we call Byzantine fault tolerance. And Byzantine fault tolerance is kind of like another level of consensus, where we're actually saying, we actually believe that there's going to be bad actors. We believe that there are going to be nodes in our database that are actively going to try to steal data, manipulate data, or do any kind of bad number of things to the network. So with Byzantine fault tolerance, you have like a voting system, where on each block contains a set of transactions. And we actually have to ask 3/4 of the nodes, are these blocks correct? Are these blocks valid? And if we start to have people that cheat us, we won't let their transactions in unless they take over an overwhelming majority of the network, which at that point they own the network anyways. But if they do start to cheat us, we start to steal, we take their resources, so we penalize you. So like if you're a bad node, we actually penalize you. So we'll take some of your Bitcoin, or we'll take some of your Ethereum back. And that's how we actually create a network that has consensus with bad actors and people that are actually, because there's actually big economic incentives. So if you look at a blockchain like Ethereum, there's probably $1 billion worth of value on the blockchain. So if somebody could steal $1 million by having bad code, they would probably try to steal it. And this has actually happened to smaller blockchains, where somebody would attack the network with a 51% attack, and they would actually steal Bitcoins from the network. So that's why it's very important that our consensus algorithms actually are taking into account that people are going to be bad. And really quick, so like I said before, Raft is really good for kind of systems that have trusted peers. So if you're in a bank and maybe you have a private blockchain for a bank, and it's only between banks, something like Raft is probably okay. So JP Morgan actually has their own blockchain in Go called Quorum, and they actually use Raft underneath it. And because they're in a mostly private, mostly trusted environment, right? So that kind of works for them. For us, we build very public blockchains for games. And while there's not as much economic incentive to try to cheat in a game, a lot of gamers really love to cheat and love to attack the network, and they would love it if they were able to like make themselves the winner of every game. So underneath ours, we use Tendermint, which is a Byzantine fault tolerance system. Once again, written in Go. It's really amazing for this kind of purpose. So, wow, this is like a lot of stuff. So I did want to just touch on this because you have to see this. Like, you can't have a blockchain talk and not have a Merkle tree slide. And then everybody's going to smile and be like, oh, that looks really impressive. And they're like, okay, I'm not going to really care what that is. But basically, just like the 10-second overview, if anybody ever asks you what a Merkle tree is, or whatever, if anybody ever asks you about a blockchain, you just spout this about Merkle trees, and then they'll think you're really smart. So basically, the whole premise of a blockchain is that each block, we generate a hash. So maybe it's a SHA-3 hash, it could be a SHA-1 hash, or whatever. And then each of the blocks that combine, we take hashes of those hashes. And then we ultimately make the tree, and then that way we can detect that the network is secure because we keep taking hashes of hashes. So even if we have, like, we can validate that some piece of data is correct without having to compute all of it, because we can see that all the hashes match on all the nodes. And that's basically really all you need to know about Merkle trees, is that it's basically just the tree of hashes that actually ultimately map up to each other. And if you can say that, then everybody will think that you're an expert on the blockchain, and you'll actually be ahead of about 99% of all blockchain developers. So, cool. I'm just going to touch on this lightly, because I feel like this talk has gone very deep, but I do want to just show one or two pictures of like what the architecture of an actual blockchain is from like the actual developer standpoint. And I know a lot of people here will probably just be writing smart contracts, but I think like I like to know the architecture of MySQL, even though I didn't build MySQL, right? So what's kind of interesting is it looks like a very traditional database. So, or a clustered database anyways, right? So at the very bottom, we have a P2P layer, and that's what we talked about with Raft, and we talked about with Tendermint. And the P2P layer and the consensus are kind of combined, because there's more than just the P2P, we have economic consensus, which we talked about. The next level is where it kind of gets interesting, where it's kind of like you start to build your own database. So we actually use LevelDB, but you could conceptually use any database. But basically, what you're doing is you're keeping a database of all the transactions, all the blocks, and then all the state for all the smart contracts. Because basically, what happens is all the blockchain is a giant mutable key value store at the end of the day. And all this other stuff is kind of just fluff above and below the key value store. Either we have coins, but coins are just a hash table inside of our key value store, essentially. And then that's when we're talking about materialized views. And then some blockchains have special query layers. So what's kind of really interesting is with a blockchain, it's a database that can go backwards in time. So you could say that on July 13th, how much money did this person have? Between these dates, how many transactions happened? Right? Because it's a blockchain it's a database that stores the history forever. So you can always query it at any point in time, which is kind of interesting. And for the storage layer, there's a lot of really common options in Go, like LevelDB, RocksDB, SQLite, BoltDB. We use LevelDB just simply because it's the most well-supported key value store, basically, in the Go ecosystem. I know a lot of people now have moved on to Rocks and Bolt. They're all really good options, but these are really fun, too. Has anybody here ever needed to use a key value store in Go, like just like a raw key value store? A couple? What reason did you have? Okay, yeah, that's actually a really good reason to have to build your own local cache. And would you? How about,
same thing, kind of caching, storing like details for short periods of time, so just use Redis.
Yeah, having your own Redis. We found that like a lot of times our Go apps were a lot faster than Redis, than going over the network. Yeah, it's the same with you, with actually storing it in LevelDB. So I kind of want to tie this together. I know this is like a very broad talk, but I kind of wanted just to give an overview, because I know a lot of people here haven't used blockchains before. You didn't know what they were for. You didn't understand, like, is it actually relevant to Go developers? And I just kind of wanted to like walk through and show, hey, there are some real use cases. You know, if you're building games, if you're building things around digital currency, there's a lot of interesting ways. Or if you're trying to find funding for a startup, there's a lot of interesting new economic ways where you can fund applications through the blockchain. And we're seeing a huge revolution in people raising $10, $15 million overnight for their blockchain applications. So there's a lot of opportunity, even just in that aspect. But there's a lot of gotchas. So I started this with a bunch of flowery language about how blockchains are great, but blockchains are way more difficult than using a regular database. So if you have a choice and you're building a normal application, don't use a blockchain. I know, I just wasted 40 minutes to tell you not to use the blockchain. Sorry. So we actually have, one of our first projects was we built a Stack Overflow on top of the blockchain. So basically the idea was that you would build comments and posts and karma on the blockchain, and then as people upvoted you, you would get tokens as rewards, and you could use those tokens to get money or other prizes and things like this. It was like an incentivized system on top of the blockchain. So like that aspect of it worked really well, but then we had lots of issues. So like all of a sudden, the consensus on our database would break. When you have MySQL doesn't break that often. It occasionally breaks, but when you actually have to dig in and try to like debug the P2P layer of your database, you start to question your decisions on why to use a blockchain, right? So we were obviously paving the way because we were kind of one of the first people trying to build large-scale applications in the blockchain. And what we're trying to hope is that we help start to mitigate some of these issues, where we make it easier to debug like consensus issues, debug like databases not being in sync with each other. Because on top of it being a distributed database like Cassandra, you have all these other implications of security too. And at the moment, it's still early days, but what's kind of cool is if you like really fun challenges and you like to build big pieces of infrastructure, there's a lot of really awesome challenges that people are still not tackling yet. And I want to kind of leave some time for questions, so I just want to wrap it up pretty quickly here. Basically, there are times when you want to build custom blockchains. So this is Takua's, and we build chains that are custom. They're not like the main Bitcoin, they're not the main Ethereum. They're custom blockchains that interact and partner with other chains like Ethereum, but they're application-specific blockchains. Hopefully from this talk you got at least some of the ideas of like how to get started building one in Go, kind of just a general overview. And really, just to know that they aren't this magic solution, because obviously we hear it everywhere, probably everywhere you read online, that we should use blockchains for everything. And just really quick, with Loom Network, we have a blockchain programming hackathon this weekend in London. And then the weekend after, we have one in New York. That's probably a lot less likely, but if you guys want to come, feel free to hit me up and I'll get you guys entrance. But it's kind of a lot of fun. We usually do gaming blockchain, so like usually over a weekend we spend 48 hours just coding games, so it's a lot of fun. So cool. I'll leave it for some questions then. All right. Cool.
So I think the concept of like the owning the assets for the games are really cool. I mean, I play a lot of games, own the swords, sell the swords, that kind of stuff. But you said people can fork it. So aren't you concerned about like the competition? You take all this time to build up this game, and then what happens when somebody says, okay, I can take this content and build a better game? Like, how do you protect that?
Wow, the first question is really the hardest. So yeah, actually, so publishers have been the most reluctant. That's why we're a tech company, but we're building one of the first games, not because we wanted to be a game studio, but because it was a hard sell. But one of the things that's happening is games are pre-selling items to fund the game. So for us, we pre-sold about $500,000 US worth of items in the game. And we didn't even do that good. I mean, that's okay, but like one of our competitors just sold $2 million in items in a game that has not had a line of code written yet. So so basically what players are saying is that they believe that there could be economic value in these items later on. So they'll help pre-fund the game. So that takes a lot of the economic risk out for the publisher. So that's the main thing. So can people fork it and steal it? Yes, but there are other pluses and stuff like that for the publisher also. Cool. Other questions? Yep.
don't blockchains like slow down when they get bigger and have more transactions, and how do you mitigate that?
That's an awesome thing. So don't blockchains get slower as time? Yeah, so it's a database that stores the entire history of time. So what there's a couple techniques where either you can compress portions of time. So what some people will do is they'll say, after a certain point, we have a Merkle hash from 90 days ago. And we're going to say that all the data before that, we're going to remove from the chain. If somebody has a backup of it, they can verify that at that point that was what the data. And we can just store it from that on. But because we're keeping track of it at all times, even if we lose some of the historical data, we'll still have the Merkle hashes at different points to know that this is still the same tree. So for our chains, that's what we intend on doing. We're probably only going to keep like 3 or 4 months of data because more than that on a game isn't that relevant. Cool. Other questions?
Just following up from that, obviously for the gaming, you're going to throw away the gaming data because it's not so important, but in sort of financial scenarios where people want, or contract basis where there's real value there, would you not want that historical, and what are people doing about it?
Yeah, so definitely. So most of the major blockchains like Bitcoin and Ethereum haven't ever thrown away data. At some point, they'll probably come into a situation where they'll have to because they'll have just grown too large. But I think what will happen is that there can be third parties that could just store it forever, right? So like I used to work in the financial world, and like one of the services we offered was 10-year storage in a vault, right? And maybe at some point somebody will do that with blockchains. But right now, we just copy the entire data set. Other questions? Somebody? Nobody? Okay, 1, 2. All right, cool. Thanks to you guys.